I'm going to talk about sex-linked inheritance, and most diseases, sex-linked diseases, are carried on the X chromosome, and most of them are recessive. So I'm going to give you one example of a sex-linked disease, which is color blindness. So let's say the normal gene for color vision is represented by a big C and it's carried on the X chromosome. So this is normal, and a colorblind gene is also carried on the X chromosome, but it is represented by a lowercase c. So this is a female who has a normal gene and a colorblind gene. She will not suffer from the disease because the normal gene is dominant, the colorblind gene is recessive. So she's not going to suffer from the disease. However, because she carries this colorblind gene, she is known as a carrier. Now, it is very important to understand in sex-linked inheritance, when you call a person a carrier, they carry the gene but do not suffer from the disease. On the other hand, if this woman was like this, in which case she had both recessive colorblind genes, you would say that she is afflicted by the disease, or she has the disease. Okay, so there are two different terms. Even though in this case she still carries both genes, you don't call her a carrier. A carrier in sex-linked diseases is one who has the gene but does not suffer from the disease. Now let's look at an example where a mother is a carrier. So this is how we will represent her. So the mother is a carrier, and the father is, let's say, as given in your book, the father is colorblind. So he has only one X chromosome. So if that has the gene, then he becomes colorblind. So in this case, he is colorblind. So he doesn't have any other gene to protect him. So let's draw a Punnett square for this. And so the mother will be like this, and this is the father. So their offsprings would be this way. So now let's see what in this case, what her who are the children who are going to be affected. This child is going to be affected. So this child is going to be affected, both recessive genes. This child is going to be affected, both recessive genes. Or rather, one recessive gene doesn't have a protective gene. This child is normal. This child is a carrier but does not have the disease. So this one is a carrier. So if you are asked, as the questions are, what percentage of their children will be colorblind? So of 4 children, 50% will be colorblind. So 50% will be colorblind. So these two will be colorblind, this one and this one. And then says what percent of colorblind individuals by sex? So by sex, so there are 2 males. So of the 2, 1 is colorblind. So therefore 50% males will be colorblind. And here again, 1 female of 2 will be colorblind. So 50% females will be colorblind. Then it says what percentage could be expected to neither exhibit or carry the allele for hemophilia. So here is asking you, out of all the 4 children, which child is absolutely normal? That means neither does the child have the disease, nor does it carry, does the child have a carrier status. So that's only one. Only this child is normal. So 25% of 4 children are normal. And then the last is what is the anticipated sex and percentage of individuals who will be carriers for hemophilia. So what percentage of individuals? It's not asking you at this point. It just says what percent of the children will be carriers. So 1 child will be a carrier. So 25% will be carrier status. And what is the sex of the child? The sex of this carrier child is female. So this is how you're going to do sex-linked inheritance. So I can give you another example where, let's say, here we say that the mother has the disease but the father is normal. So, let's say, so the mother has the disease and the father is normal. So here is how the Punnett square will work out. Okay, so now if you look at this, we can see that this person, this girl is a carrier, this girl is a carrier, this boy has the disease, this boy has the disease. You can see that the boys always get the gene from the mother because the X chromosome comes from the mother. So the boys will always get the gene from the mother. If they get the gene, they will suffer from the disease. So out of 4 individuals, 50% will have the disease, 50% will be diseased, and 50% will be carriers, as you can see here. And then what percent of the 4 are carriers? Again, 50%, as we said, are carriers. Of the males, how many males are diseased? 100%, because 2 possible males, 100% of males are diseased, of males. And 100% of the females are carriers. Okay. The other thing to know is, you can see, in order for a woman to be diseased, she has to have both recessive genes. In this case, as you can see it, she has to have both recessive genes. If she has only one, then she has a carrier status.